Hello guys, myself again. This video we should see another problem on LeetCode. Minimum stack. So design a stack that supports all this operation. Push, pop, top means the topmost element of the stack and retrieving the minimum element in the constant time. So we need to have a stack class, minimum stack. In that we need to implement one minimum stack that initializes object each time. Then push means pushing an element to the stack, then popping and removing an element from the stack, then getting the topmost element from the stack and getting the minimum element in the stack. So if you see the questions, to get the topmost element within the stack, you can find a topmost element. But to get the minimum element, what we need to do? For that, let's maintain another stack called minimum stack. So we will have two stacks apparently. One is the main stack, and another is the minimum stack. The main stack contains whatever elements you push, pop, or push that into the stack that will contain. But minimum stack contains only the minimum elements. So how does it work? Let's take this only example present. So initially minimum stack you have and both are empty. Then you are pushing -2 into the stack. So you push -2 into the stack. So once you push -2 into the stack, the minimum stack is empty. That means -2 will be the lowest minimum value for now. So you push -2 into the stack, minimum stack as well. So next you push 0 into the stack. But when it comes to minimum stack, if 0 is less than -2, no. So you won't push 0 into the minimum stack. So minimum stack will contain the minimum value -2 itself. Next you push -3 into the stack. Here again you check whether -3 is less than -2. Yes, it is. So you push -3 into the stack, minimum stack. So after this, you have to get the minimum value of the stack. So that is nothing but the topmost value of the peak value of the minimum stack. So you return -3. You're not popping, but you're returning -3. Next, minimum stack dot pop. You're performing pop operations. So pop operation means from the main stack we are popping the element that is -3. So this will be popped out. But when you pop -3, you have to check whether this value is equal to the peak value of the minimum stack as well. If they're equal, then you delete this as well, pop this as well. So in this case, -3 -3 equal, so pop -3 from both the stack. If this is not present, then okay, only from the main stack you pop the element. So after popping, then you're getting top of the stack. Top means topmost value of the main stack. So which value it is containing topmost value is 0. So it is returning 0 over here. So next, again you get the minimum of the stack. So minimum value you can see from the minimum stack top value that is -2 because -3 is popped out already. So you return -2. This is how the problem works. You maintain two stacks. First stack contains the main stack, all element you push, but in the minimum stack you push only element that is minimum. So as we know all, we will declare a class over here and initialize it over in the minimum stack method. So for declaring class, let's make it private. Private stack of type integer. So first one is the minimum stack. Let's name it as stack itself. Main stack as a stack. So we'll have another stack called minimum stack. So the reason for doing this we know, right? Private because this can be accessed only by the class minimum stack. No other class can access that. So access will be restricted only to the minimum stack class. Now initialize this the new object stack object inside the minimum stack constructor. So stack equal to new stack. Similarly, minimum stack equal to new stack. Right. So now pushing element. So we know we have to push a value to the main stack, of course. So stack dot push of value. But when it comes to minimum stack, we push only that element only if the stack is empty. So initially stack was empty, so we pushed -2. So when we pushed -3, we have to check whether the value which we are pushing into the stack it is lesser than minimum stack dot p. There are two cases: either it is empty or value is lesser than or equal to minimum stack dot p. Then we push the element. So you have to check if minimum stack dot empty is empty is the condition, or if that is true, or minimum stack, or I'll say value whatever we are pushing, if that is less than or equal to minimum stack dot peak, then we have to push the value into the minimum stack. So minimum stack dot push of value. After this pop, again for popping also similar method applies. So you have to pop the value from the stack. That is for sure. So minimum not stack dot pop. But we have to check whether this popped element is equal to the stack minimum stack dot peak. So here -3 and -3 were equal. So we have to remove -3 from both the stacks. So let us initialize it to one variable called int var, and now check whether that value, if value is equal to minimum stack dot peak. So if it is equal, then you have to pop from the minimum stack as well. So minimum stack dot pop. This is how we pop from the minimum stack. Next, but at the end, while we were popping after -3, we have got we pop -3, right? So again, if we need to pop 0 after all these things, if we need to pop 0, then we pop it from only the main stack. And 0 is not present, it's not the topmost element of the minimum, so it's not the minimum value. So we need not to return from the minimum stack in this case. So next comes the top. So that is nothing but we have to return the stack dot top peak, topmost element in the stack. And when it comes to minimum value, then we have to return stack dot peak of this minimum stack. So return minimum stack dot peak. Yeah. Okay. Yeah. It is successfully submitted. If you understood the problem, please like the video and subscribe to the channel. We'll come on with other next session. Until then, keep learning. Thank you.